Now let's try to find the relation between number of symmetric and number of antisymmetric relations possible on a set A with n elements. Okay, so the base is same. There is a set A with n elements. Now I'm not very sure what should be the appropriate set diagram for this. If I say that this is the number of symmetric relations and this is the number of anti-symmetric relations A, I'm not sure whether this is justifiable. I don't know whether they are disjoint, or they have something in common, which means there is some intersection part, or I don't know anything about it. Let me justify it later. Okay. Now this is the rectangular box is the set of all relations possible. So let me call it as U, and we know that the number of relations, total relations possible on a set A with n elements is 2 power n square, isn't it? The reason is A cross A contains n square elements, and the total number of relations that we can make out of these n square elements is 2 power n square. Okay, and now we already know that the number of symmetric relations possible, right, n of s, we already know this. The number of symmetric relations possible is 2 power n into n plus 1 by 2. This is the number of symmetric relations possible, and the number of antisymmetric relations possible is n of a. The number of antisymmetric relations possible just now we derived in the earlier video, the previous video. It is 2 power n into 3 power n into n minus 1 by 2, right? This is about the diagonal elements, and this is about the non-diagonal element pairs. Okay, so now I have to justify whether there exists a intersection part, which means will there be any relation in such a way that they are present, which are both symmetric as well as anti-symmetric. Now the relation between symmetric and anti-symmetric relation is, in symmetric relations if there is x comma y, there has to be y comma x, but in anti-symmetric relations, if there is x comma y, there should not be y comma x. Try to understand this. In symmetric relations, if there is x comma y, there has to be y comma x, but in antisymmetric relations, if there is x comma y, there should not be any y comma x. Only exception in case of antisymmetric relations is, if you are going to have both x comma y and y comma x, you better have it in such a way that x equal to y, right? Therefore only relations which will be both symmetric and antisymmetric will contain the diagonal elements only, right? So let's try to see. Let me name the regions once. Let me say that is region 1, region 2, region 3, region 4. Okay, so let's try to find out whether there exists at least one relation in all these regions 1, 2, 3, 4. Then only this diagram is justifiable, right? So let me try to find out R1, an example for region 1. So is there any relation which is not either symmetric or antisymmetric? So if it should not be symmetric, then we should have something like this 1 comma 2, right? But then it is going to be antisymmetric, right? So let me make it 2 comma 1, right? Now it is not antisymmetric, but it is symmetric. So just to make it not antisymmetric and not symmetric, I added this. So you must be understanding this. Because of the presence of these two elements, it is not antisymmetric. X comma y and y comma x both are present and both are different. X comma y are different. And now because of the presence of this element 2 comma 3 and absence of the element 3 comma 2, it is not symmetric. Therefore there exists at least one relation which is neither symmetric nor antisymmetric, which means the existence of region 1 is justifiable. So there might be more, I'm not sure, but then there is at least one relation. Okay, now what about R2? So can you give me any example of the relations which are symmetric but not antisymmetric, which means we want the symmetric relations but we don't want any antisymmetric relations? Okay, so simple, you can have 1 2 and then 2 1. So this is symmetric, isn't it? This is symmetric but not antisymmetric. Why is it not antisymmetric? Because x comma y and y comma x both are present. Now what about intersection, which are both symmetric and antisymmetric? The relations which are both symmetric and antisymmetric. We know that empty set is an example, isn't it? It is an example of a relation which is both symmetric as well as antisymmetric. Or if you want any solid example, let's say I want something which is symmetric and antisymmetric. 1 comma 1, this is symmetric because we have x comma y and y comma x. It is antisymmetric because we have x comma y and y comma x, and it happened that x comma y x equal to y, right? Therefore R3 is an example of a relation which is both symmetric and antisymmetric. Now let me find out a relation R4 which is antisymmetric but not symmetric. So what could be a relation which is antisymmetric but not symmetric? If a relation has to be antisymmetric but not symmetric, then what are the ordered pairs that should be present in this? So if you have 1 comma 1, or we can just say 2 comma 1, this is antisymmetric because there is no x comma y and y comma x term. Only 2 comma 1 is present and 1 comma 2 is not present. Therefore it is antisymmetric, but it is not symmetric. The reason is 2 comma 1 is present but 1 comma 2 is not present. So this diagram seems to be right, which means I have got relations in each of the regions. Fine. And also now there can be various questions. What is the number of relations which are possible on A, which are either symmetric or antisymmetric, like that, or which are neither symmetric nor antisymmetric? If we have to answer such questions, only region that we have to find out is 3. If we can find out the region 3, then we can solve many questions on this. So how to find out region 3? What is region 3 here? The number of relations which are both symmetric as well as antisymmetric. Now if a region has to be symmetric or antisymmetric, both symmetric and antisymmetric, then there should be only diagonal elements present, right? Any other element if you try to add, let us say if you try to add a element 1 comma 2, then it will not be symmetric. If you try to make it symmetric by adding 1 comma 2 and 2 comma 1, then it will not be antisymmetric. Are you getting this? So what is that I am trying to say here is, if an element has to be present. Now let's see how to find out the relations which are present in both symmetric and antisymmetric. So if you are talking about A cross A, then we have diagonal elements, isn't it? What are the diagonal elements? 1 comma 1, 2 comma 2, 3 comma 3, so on, n comma n. Now you can take any subset of this that is going to be a relation which is both symmetric and antisymmetric. The reason is simple. If you try to make a relation from only the elements of this, right, then it is going to be, let's say 1 comma 1, something like this, 1 comma 1, 2 comma 2, that's it. Then it is definitely going to be both symmetric and antisymmetric. The reason is, it is symmetric because it has got x comma y and y comma x. It is antisymmetric because it has got x comma y comma x and x equal to y. That is the reason. Now if you add anything else, if you try to add any other element, let's say like 2 comma 1 to this, then what happens is, this will be antisymmetric but not symmetric, right? And if you try to make it symmetric by adding 1 comma 2 as well, then it will be symmetric but not antisymmetric. Therefore no other elements are allowed. Only elements which are allowed to form the relations which will be both symmetric and antisymmetric are diagonal elements, right? And now if you take each element, an element may be present or it may not be present, right? And both ways it is going to give rise to a relation which is both symmetric and antisymmetric. Therefore each element is going to have two cases. So 2 into 2 into 2 into so on 2, which is 2 power n. So the number of relations which are both symmetric and antisymmetric is going to be 2 power n. So n of S intersection A, symmetric and antisymmetric, is going to be 2 power n. Now after finding out this, you can answer all the questions. So one question is, what is the number of relations which are either symmetric or antisymmetric, which is nothing but S union A. So how can you find out S union A? It is going to be number of relations which are symmetric plus number of relations which are antisymmetric minus number of relations which are both. Why am I subtracting this? Because of this diagram. If you are trying to find out the number of relations which are present in region 2, region 3 and region 4, if you are trying to write like this, what happens is, if you are talking about n of s, then it is going to be 2 plus 3, isn't it? Region 2 plus region 3, and then n of a, it is going to be 3 plus 4, which means region 3 and region 4. So if you see this, overall region 3 is added 2 times, that is why you subtract region 3 once, then it is going to be 2 plus 3 plus 4, 2 plus 3 plus 4, that is what we wanted. Therefore the number of relations which are either S or U or A, which means which are either symmetric or anti-symmetric, is going to be you can add them. So region 2 plus 3 plus 4, right? So you can add them all, or you can just do like this: n of s plus n of a minus n of s intersection a, and you know all these numbers, you can just substitute them. And now other kind of question is, how many number of relations are there which are symmetric but not anti-symmetric, which means they are talking about region 2. Now what is it? N of s minus n of s intersection a, isn't it? Now we know the numbers, we can substitute there. And similarly they might ask you number of relations which are anti-symmetric but not symmetric. Again you can solve it the same way. What is it? N of a minus n of s intersection a. You might have some other methods to solving it and getting the same answer, but then I'm just showing you a standard method which you can apply for all types of questions. If you get any other method, you can go with that, but then see that you get the same answer. Okay. And the other one is, what are the number of relations possible which are neither S nor A? So which means they are talking about region 1. If you want to know the region 1, then you have to they are like this: S union A complement, which is nothing but n of u, which means total number of relations possible, minus n of S union A. So we have already computed these two, you can substitute the numbers. So this is the relation between number of symmetric relations and number of anti-symmetric relations. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. And IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply. And statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.